Hi friends, welcome to Coordinate, and today we want to proceed in this session to understand the basics that we need to understand when it comes to the operating system. In definition, we can define an operating system as simply that manages the softwares and the hardware on a computer. A computer is any electronic gadget that holds on to electronic functions, and some of the basic tasks that an operating system can perform on any electronic gadget are file management, memory management, and process management. Of course, the thing that allows you to delete, is it a song, a video, a picture, or anything that you want to delete, or maybe is it at that point when you want to clear and empty your recycle bin, it is definitely an operating system. When you open a certain application or when you launch a certain system, a certain software on your computer, your cell phone, or your tablet, it is an operating system that allows you to do that. Some of the other operations that it can perform are accounting tasks and anything related to that. Now, types of operating system, of course, you can tell just by seeing the image. Windows is a certain type of an operating system. Then Android again is also a certain type of an operating system. Another type of an operating system, of course, the three that we've just added in this session is Mac OS. That is also an operating system. Other types are Linux and all the other types of operating system. And the other thing that we need to understand in these basics, of course, before we proceed in the practical approach to operating system, is simply understanding what a CPU is. A CPU, which is shortened Central Processing Unit, is simply a central processor. The many processor or just a processor, those are the three names that you can replace on CPU. Now, its function, like many people define it as the heart for a computer, is simply to execute the instructions that are comprising a computer program. When we code, when we present our code here on Coordinate, the thing that allows to translate those codes into something that is sensible and that can make sense is simply a CPU. Hence, it is actually the heart of a computer because it is the fundamental key mother for any computing device. And this is actually its view in laptops. That's how it looks. Though many people say you don't tamper with such types of systems, you don't mainly add physical impact to your CPU. It might just boom, PC might just stop working, and of course you might start questioning and of course doing all the other things. And if you have a desktop, that is the actual view. I'm sure you can tell you have your CPU, that's how it looks, and of course that is how it now looks when it is on the motherboard connected to all other components. And you can tell on the way it is attacked and connected to certain devices that definitely it is the mother component. It is actually the heart of a computer because each and everything is connected to the CPU. Then what other things do we need to understand? Well, there are key terminologies that we need to understand and see on how we can use them when it comes to operating system, because frequently, day by day, as we present our work, we'll be talking about these terms frequently. Hence, we need to understand, hey, what are these terms and what can we understand when we understand these terms? So, a process is simply a running program, a program that is under execution. Is it when you launch your camera on your cell phone? Since it is the thing that is running at that time, a camera can be referred to as a process. When you open, is it any software on your PC? Is it Microsoft Office or anything related to that? Since it is the thing under execution, it can be referred to as a process. Now, for we to have a complete process, we need to follow these steps. Actually, the computer follows these steps. A process needs to start. That's where you click on it, and then after that, the process needs to go in the ready queue. It should be in the ready state. A ready queue will be discussed in our next slide, and definitely from there, it needs to run now. After starting, it will be in the ready queue. It will be ready, just awaiting for the CPU to allocate. And this is the point where we find now the CPU, because the process needs to be running executing. After running, a process can either be terminated, meaning it's completely done, or if not terminated, then it can go back into waiting state, and of course waiting back into the ready queue based on the algorithm that is being followed or that is being used. Now we need to understand, hey, what is a ready queue? Because here we are just saying, okay, it needs to be in the ready queue. So a ready queue is simply a queue of processes that are awaiting to be allocated or that are awaiting to be appointed by the CPU that yes, you are next to be executed. So the process is loaded into the main memory, which is the RAM, and will be placed in the queue of processes which are in the waiting state because they are not yet executing. They are in the RAM and they are awaiting to be executed by the CPU. So that is what we call a ready queue. Simply a program that you want to run, but it is not yet running. It is waiting for the CPU to appoint or to say yes, you can run by now. So that is a ready queue. So since it is a queue, definitely we can say, okay, it might be a line. There should be an order. So this is how the ready queue operates. So this is process, of course, in front. Then we have process 4 at the back, process 1, which is before process 4, and then we have process 3 at the back, like on the very last queue, because it is not yet in the state of running. And then the ready queue is next to the CPU. Hence, from here, the CPU will select each and every process that it needs to execute. Other terms that we need to understand is simply preemption scheduling and non-preemption scheduling. What is preemption scheduling? The word preemption simply meaning something being disturbed a bit. So we can define preemption as simply the act of temporarily interrupting an executing task with the intention of resuming it at a later time. So what we are saying is, when a certain program is under execution, if it is running, it can be interrupted or it can be paused, stopped. It even stops running for another process to start running now, but of course it is not yet done. It can be, of course, terminated because it is not completely done, but it will return at a later time for it to complete. A best scenario we can give is simply how a camera works. When you want to capture someone using your cell phone and then you receive a phone call, definitely the camera won't proceed running. No, it won't. The camera will of course be in waiting state again, waiting for you to finish answering the phone call, and then from there you proceed with the camera and taking of the picture and anything related to that. So that is what preemption scheduling is. Non-preemption is simply the exact opposite of preemption scheduling. Non-preemption simply entails that this thing cannot be stopped, whether such comes in, whether what process comes in, it needs to proceed until it is terminated or it reaches a waiting state. The best example we can give is how a song actually works if you are using your laptop. If you are playing a song can't be stopped just because you want to open another application, like you want to open just because you want to open Microsoft Word. No. The song will proceed playing. It will play until it finishes. That is non-preemption scheduling. The process will continue until it is terminated. Other types of terms that we need to understand in our basics to operating system is simply waiting time. Waiting time is simply the time that a process will spend in the ready queue before it is executed by the CPU. How long did it wait in the ready queue before it was caught by the CPU? That is waiting time. I'm sure you can tell by the name. Waiting. It is not yet under execution. Then turnaround time is simply the amount of time taken for a complete process to be fulfilled. If the process is now called in the CPU, how long did it take for that process to completely be fulfilled, or for that process to completely be terminated? That is turnaround time. You can even see the difference. Waiting time in the ready queue before the CPU, turnaround time in the CPU, complete time taken for that process to be executed. Now, burst time. What is burst time? The total amount of time required by the CPU to execute the whole process. You understand the actual difference between turnaround time and burst time because they sound like they are similar, but they are totally different. Turnaround time, the actual time spent, but what is the total time that was required by the CPU or that is required by the CPU for this process to be executed? That is burst time. So this is the actual basics we can actually have when it comes to the operating systems and how they can be implemented. Hence, let's proceed on our next session because we want now to start understanding the practical approach to different algorithms and how calculations and computations are asked, is it in an exam, and on our personal point of view before we understand the other types of algorithm. The very first algorithm that we understand is first come, first serve scheduling algorithm. Hence, like we specified from our introduction, boom, we are now digging into the practical approach to operating system, which is of course what we will be doing in our next session. Please don't forget to subscribe, and you are on CodeNet.